hopefully, I think assignment 1.1 is due today, so I will collect it at the end of class. 맞지? Hopefully everyone finish your assignment. Everyone should finish. Hopefully they finish their assignment on time, and I will take a look at it today. And if I have a chance, I will select a few and ask them to show their clocks if it's good ones. Anybody did any digital clocks? Raise your hand if you did a digital clock. 오, 많이 했네. Okay. So I will definitely take a look. Was it easy? It wasn't that easy. 이거 별로 쉽지 않았을 텐데. 쉬웠어요? 그죠? Digital clock might be Googling. Google is my friend. Be careful when you try to use some of the source codes from Google. Sometimes they are copyrighted, or sometimes you're not allowed to use someone else's code without any permissions. So sometimes you need to be careful. But if you download the open source and change a little bit, then I guess it's okay. For academic purposes only, for our use only. So there was a lot of examples on digital clock processing in Google too. 진짜? Processing is wonderful language, right? 재밌죠? Especially if you like to do some art, fancy pure graphics, it might be a good place to start. 그런 데서 많이 하더라. Modern art. 그런 데서 많이 하더라. So I don't have too much knowledge on those processing, but it seems to be a very nice tool to begin with. Hopefully you can build something new. You can certainly build something with the processing and upload on your web page. If it's HTML5 ready, then I think it will be okay too. So I'm glad that you guys enjoyed that assignment, and I will collect it at the end of class. So last class we were discussing Python, right? Now we're gonna switch from a processing. Processing was just giving you a taste of different type of languages out there. It's always nice to build something in visual. You can see what it does right away. That might be a fun part to do that. But languages like Python or high-level languages in like C, C++, sometimes they don't have any graphics in it, so you might be bored. So, 어쩔 땐 별 재미없죠. C나 짜면. Unlike the processing. So, switching from processing to Python, and we briefly look at a few examples in Python. I give you certain websites that you can go to. 오늘 왜 이렇게 어수선하지? You guys have assignment for next class too? 지저분하네. 오늘 이렇게 약간 너저분합니다. A few examples on the Python, how to write a function in Python, how to generate the organized looking Python code, the loops, and file opens, and there are examples that you can try on the website as well. Hopefully, then you will be able to finish your assignment 2.1 just asking you to build a robot to exit the maze. It's not fancy graphical, but it's something that you could think of when you do start that program. Just open up the file. Example of open up the file, reading something from a file, make a decision based on the current situations, looking at whether you have obstacles in front of you or not. Those type of things hopefully give you a chance to think of your own algorithms in pseudocode. 그리고, and then we discuss a bit of the OOP, right? Object-oriented programming. 그죠? 아닌가? Again, every single time I feel like I'm in different class. 그죠? Every week. It doesn't matter last week or this week. OOP example, we looked at simple example like mammals, animals, classes, you can certainly try those classes, create your own classes, extend your own classes to be some other classes in Python as well. They give you very simple syntax on defining your own classes, but it's nothing much, right? If you can find out the characteristics of your object, write it down, and each class object have their own functions to execute. So some of the problems, the programming examples from your textbook was referring to creating your circle object, creating your rectangular object from a maybe basic shape class, things like that. And each object has a separate function like calculate the area. Those functions may be common, but you need to change it a little bit because every shape has a different formula for calculating the area, calculating the space. So those type of stuff hopefully give you some ideas on what OOP is, and I'm sure that more details will be covered in your next semester courses in Java or C++. So that was what we covered till last class, and your midterm is coming up, and I think after we finish this chapter, we're going to discuss briefly on the review of the stuff that you should look at for your midterms, and we'll see after that. Okay, so in this chapter, it's a brand, yeah? I don't know. I haven't decided yet. I'll let you know next week, sometime next week. But before you look at the Python, 생각해보면 when is the due date of the Python programming exercise? Which is after the midterm. So there will be a less chance that I might ask you those Python questions, right? 중간고사 이후죠? 아마 파이썬 숙제 듀가 그 다음 주인가 그렇죠? 그러면 아무래도 좀 안 물어볼 가능성이 좀 더 있지 않을까? 그죠? Otherwise, other than Python, you might have a lot of stuff to look at anyways from other chapters, at least covering chapter 5 to 6, blah, blah, blah. But I will discuss more on the coverage next week. So, from the new chapter that we're going to go into, start discussing something called system programming. System programs, system softwares. It's a big softwares. Programs that we have looked at for your exercises, algorithms that we briefly discussed. Those are very tiny examples. Systems that you actually use, your operating system, your Windows, I don't know, your compilers that you use to do your programming exercises. Those are type of softwares that is really big piece of softwares. 얼마나 하지? How much is the Windows? If you try to install a brand new Windows, what is the usually size of the Windows CD, DVD file? 얼마나 하니? Probably more than 2 to 3 gigabytes of a files. 옛날에는, long time ago, Windows XP, what? Only like 700 megabytes, 600 megabytes, right? Newer versions of OS. It means they contains a lot of system softwares. They require more and more. So we're going to take a look at what is a system softwares, what is the main categories of the system task, what your computer should do. We've been discussing, we have looked at some examples on machine languages, right? 0101 ways. But I also ask you that questions like, do you want to do your program in that way all the time? I want to use the assembly opcode every single time you try to do a program? Probably not, right? So Compare the virtual machines created by for the users by the system softwares with the naked machines. Naked machines. What is a naked machines? Yeah, more dumb hardware, CPU, and stuff. Virtual machines. In the big picture, it will probably look like your Windows. Why Windows was so successful at the beginning? 왜 잘 나갔지? 하긴 윈도우밖에 안 써봤으니 뭘 비교할 게 있어야지. 그죠? It was easy to use. Users are quite as soon as we start looking at the screen, we can figure out it has a nice features in it. That was so this system software is the main goal of the system softwares. They try to create more friendly environment, easy environment to use our CPU and memory. So that was probably the main goal of this system softwares. 아니면 if we don't have Windows, then what? We have to, if you want to use our CPU and hardware, then we have to do opcode every single time. Assembly, add R1, R2. You don't want to do that every single time, right? Explain the benefits of writing system software in assembly languages rather than machine language. Assembly language, we already seen. The programming examples that we have used, opcode, add, load, store, those are type of thing. If you try to write a program with those type of instructions, that's assembly language, program in assembly language. If you translate those assembly language through the decoder, 0101 everything, then it's going to be a machine language. Okay. So why is it better to write a code in those fashions? It's obvious. It's better to look at the actual strings, characters, than 0101. 0101면 써놓으면 복잡지요. So it's quite obvious. We're going to take a look at a few examples on that part. Read and write short assembly language programs. So your assignment 3, maybe, 기억이 안 나네. Yeah, probably your next set of assignment, written assignment, will probably ask you to write some program in assembly code. The simple translation, very simple translation. And I believe computer architecture course, 컴구조, which you will take in second year, they will also ask you a similar programming experience, but much longer and a bit more technical ones out there. Describe how the assembler translate the assembly languages program into a machine instructions. Blah, blah, blah. More details will come up. List 5 key tasks of a operating system, explaining what each is, why is critical to modern systems. What is the main purpose of your operating system or your Windows? Key task, not purpose. What is the main function of your operating system? Windows we call it as an operating system. 꼭 해야 되는 5가지 기능, key features. 뭐가 있을까? We'll take a look. Describe the different generations of operating systems, what features each generation were, each generation solved drawback of previous generation. I don't think we're going to discuss this too much. I don't want to look at some of the histories of operating systems. What I care is what's happening now. So, okay, that's a brief overview of the entire chapter, system software chapter, that we're going to take a look. Again, mostly introductory. Operating system is your second year course too. When you take those courses, then it will be much more clear, more details, programming details, and the concept they cover in that too. 아마 most likely I will be teaching operating systems too in your second year. 또 보겠네, 그죠? 안 봐야 되는데, 그죠? 근데 자꾸 보게 될 거예요, 어쩔 수 없이. Naked machines has no tool, no program to help the users. Nothing, just pure CPU and memory, computer board. So in order to tell the CPU do what, you have to program in binary code, only 0101. Long time ago, there was few examples that we saw, like ENIAC, those videos. They have lots of switch, right? I don't know if you remember from that YouTube clips. I have a switch large, and people having a piece of paper and look at paper and flip. There was a small, short moment of showing that operation. That's what. They're actually doing a programming. Switch on, 1, switch down, 0. So they were actually doing a programming, standing up and flipping switches. So that was the way to do the programming in binary. We don't want to do that every single time we do a program, right? So hopefully system software will help us to find the easier way to do it. Write a data in binary, converting decimal digit into binary digit. So again, flip, even for the data sets too. Load the instructions to a memory 1 cell at a time. Initiate the program run, blah, blah, blah. It is too difficult for us to do every single time. Usually, programming requires a repetitive task. The reason we're using loops in many cases because it's just asking to do the same thing over and over again. That's one of the advantages of having a program, right? We must build an interface to hide the details and make the computer easier to build. Build a interface. interface가 뭐지? Interface. It's like adding another layer. So me, computer, we usually go directly convert everything into binary numbers and did it. Hopefully we can add something in the between that translate what I want to do into a binary. That's what usually the program, the compiler was doing, right? Whatever I wrote in my program in Python C, that is somewhat doing something to tell the CPU do what. Right? So those type of ideas for interfaces. Also user interface that we know. User interface. Hopefully we can easily use it. So system software definition, it's not the only definition, but it's easier definition of system software. It's a collection of programs to manage resources of the computer. Serves as intermediary between user and hardware, between you and CPU and memory. It says also manage resources of the computer. What is a resource? resource가 뭐지? What is a resource in Korean? 자원. Yeah. What is 자원 in computer? Memory, CPU time. How much CPU time could a single program can get? Disk space, also resource. So it's a big program that manages a resource among the programs in your computer, in your system, to be more exact. And it is a service intermediary between user and hardware. Something that stays between you and hardware, like I mentioned, interface-like. System software create a virtual machine or virtual environment that user sees. So what I see on my screen is something virtual. Virtual means something that doesn't exist. So, but it's nicer to use. I mean, what do I see in my screen if I'm assuming that I use Windows 7? What is my first screen? Windows 7 뭐 뻔하지 뭐 start button. I never used the Windows 8, but they say they removed the start button. It looked like a Windows 8 쓰는 사람. 거기 진짜 스타트 버튼 없어요? Windows 8.1 they said they will bring it up. So those type of, but those things are all fake. I mean, when I'm clicking those start button, I'm actually asking something to the Windows to do something. It means also I'm asking to do something for the CPU, to the CPU. But it's all through a fake environment. but easy to use, easy to look at. So this is what the picture like in your textbook. Interface A, virtual machine interface. It goes through the virtual interface that created by one of the components of the system software, and then it goes to translate into actual the machine languages and goes to hardware, tell CPU to what to do. If I click on the start button in this machine right here, this is Windows 7인가? So if moment that I click on the start, CPU jump. CPU jump means that CPU is doing something. So utilization, they usually say CPU utilization, how much of the CPU that I'm using, those things will jump. So actually I'm telling something to the CPU. As soon as I click, that messages somehow translate into machine languages doing something. So you can actually take a look at those type of your interactions. 일반적으로 interaction이라고 많이 하잖아. 친구랑 만나는 것도 뭐 interaction, social interactions. Same thing. And the main part of the system software is a operating system. What does your Windows do? 뭐 하지? Without operating system, without Windows, can you boot up your computer? No, right? So it's a very basic component of the operating system. Without operating system, can you do an internet? Right? Internet basically is in order to do an internet, the programs in your system must be communicating over internet to another program on someone else's computer. So you need operating system in those activities. So communicate the users with the users, start up the system software applications as needed. Sometimes you can configure the start programming in your menus. 그런 거 잘 안 해요? Do you guys do a control over which program to start right away? 그런 거 잘 알아? Some programs ask you when you install those programs that, do you want me to start at the boot up time? 옛날에 메신저 같은 거나, or your Facebook pages, or 또 뭐 있지 요즘에? Vaccine, 맞아. Oh, I hate those vaccine programs, but they usually start right after the operating system starts. How many of you are using those anti-vaccine programs, antivirus programs? 백신 쓰는 사람, anti-vaccine program도 있고 있을지도 모르지. People like me, I don't like the anti-vaccines. And antivirus softwares. Graphical user interface, GUI, often pronounced as GUI. It doesn't matter. GUI. Visual interface to the operating system or other system software applications. What is so good about Windows comparing to maybe Unix? Like systems. Well, Unix also has a GUI too, but why Windows was successful? Because it has a very pretty screen. It has boxes too. 뭐죠? 제일 유명한 게 이런 거 있잖아요. This is my program and it has button like this. Anybody can figure this out without explaining what it is. So even if your IQ is below 50, they know it looks like, oh, click on it. Or even though you don't know what to do, but you just simply go and click and figure it out. Those type of magics, user interface, was a very crucial part of a success of the certain operating systems. So easier to use, again, easier to use. Nowadays, Ubuntu or any others ones, those also provide a very nice GUI. So it's not just Windows out there too. You can certainly try other systems as well. 일반적으로 프로그램 고를 때 you have a set of programs that do the same thing. What would you prefer? Easy to use maybe and pretty looking. Just like why iPhone was so successful. iPhone was, their user interface was so successful. So pretty, 아이콘 이쁘게 해놓고 스칼라 이쁘게 해놓고 그 별거 아닌 것 같죠? 그런 회사들 그런 거 할 때 심리학자, 디자이너들도 막 심리학과 디자인 동시에 하는 사람들, 버튼 크기 이런 거 엄청난 노력을 들여서 어떤 버튼 크기가 가장 사람들이 거부감을 일으키고 가장 많이 클릭하는지. I also heard that when you're using a Facebook, sometimes you enter into a menu, some menu, whatever you can leave a message or something. Sometimes your friends and you, they do the same thing. The screen looks different. It's doing this exactly same thing, but the menu looks slightly different every single time. I heard that the Facebook is testing new user interface every single time. And they find out, oh, people click more on this user interface, this box design, than previous one. And they figure out in that way, and then maybe they change the new UI. So UI is a very, very important part of the, not just system software, other ways as well. 그런 식으로 테스팅 한다 그러더라고요. 동시에 이렇게 같은 데 들어가서 댓글 들어가는데 어쩔 때는 어떤 사람 웹페이지에는 버튼이 좀 크고 색깔이 좀 변해 보이고 이렇게 한대요. 그래서 둘 중에 사람들이 더 많이 클릭하는 거를 결정을 해갖고 나중에 그거를 바꿔버리고 그런 식으로 테스트 많이 한대요. 그래서 상당히 재미있는 분야입니다. 자기가 색이나 그림에 소질이 있고 뭐 인더스트리얼 디자인에 소질이 있을 것 같으면 프로그램도 좀 할 줄 알고 하니까 이런 것도 나쁜 직업은 아닌 것 같아요. 어렵지 근데 좀. 소위 말하는 삽질이 가장 많이 일어나는 분야가 UI 디자인하는 애들이에요. The newer terms are used in 요즘에 뭐라 그러는지 알아요? The newer terms for UI nowadays. 혹시 anybody heard that? 누가 얘기한 것 같은데? UX? 혹시 이런 거 못 들어봤어요? User experience. So there are a few companies, many companies actually try to, it's next generation of UI. They try to create a nicer user experience, pretty graph anyways. And your processing is one of the good examples for UX. 프로세싱으로 좀 이쁘게 클릭하고 만들어요. 어떤 웹사이트 가면 프로세싱으로 웹사이트를 만들어 놓은 데도 있어요. So there's a visual interface, what you see, what you get. I/O systems communicate with the various devices. I/O systems referring to 뭐가 있을까? Your keyboard. I/O input and output systems. Your DVD drive, or even your hard disk too. I/O devices are there to use it. So if you classify, well, it's not the only one classify of the operating system. This is what operating system, one of the central operating system software is operating system. This is what operating system, the functionality of operating systems. 5 functionalities. Again, this is not the only one classification. Operating system must support the language services. Language services. It says support high-level languages. High-level languages. What are the examples of high-level languages? language가 뭐야? 언어. Java is high-level languages. Again, others. C is your high-level languages. C++, high-level languages. Python, high-level languages. High up. I know you guys don't feel that those languages are easy to use yet, but it is actually easy to use comparing to the machine level languages. It's much easier than 0101, right? So that's why they call it as high level languages. So your operating system must support, must have some type of other programs that understands the programs in high level languages. So they require things like compiler, assembler, interpreter. Compiler, when you write your C program, you click on compile, that it will translate whatever it does and translate back into assembly language. Assembly language will be translated into machine language, so CPU can find out what to do. So, I think last chapter of the course probably give you idea for compilers. A few examples on the compilers. So those are also big system software too. And memory management. Operating system must be dealing with how to organize the memory space. Memory is the place that we write our program on. Wherever I type in, it will be going into a memory, your memory RAMs, and from that point, operating system will execute that program. So it must know how to, it's like loaders, think of it as store, load, those type of operations must be supported by memory management. Information manager, organized mass storage, database, file system. Database, you might not know what it is at this point now, but you're using it every single day anyways. Go to any website. 쉽게 put하면, easily put, if you go to enry.com, when you click on certain menus looking for cars. 남자들은 자동차 신차 메뉴 많이 들어가요? 안 들어가요? 여러분들은 그게 아직 안 들어가는 거야. 차에 관심이 없구나. 신차 메뉴 뭐 이렇게 들어가면 there is category of cars. Each brand has it. If you click on that part, then maybe if I click on BMW, then they show the cars from BMW. So the system that displays those type of information is a database. They have information about each categories, and then website, we're using the website to get those information out of from this database systems. But those are a bit later. Scheduler, manage programs waiting to run. This is also more detailed materials in the operating system course, but briefly explained. How many programs are you executing in your computer at this moment? How many programs are running at the time? Get 20? Let's see how many programs are running in this laptop. Task manager, go to the menu, process. Ooh, okay. This is the total number of programs running at this moment in this computer. Many. 그렇죠? 몇 개야? 얼핏 봐도 50개? 51개요? 51개 써있네. 51. And it takes around 39% of the memory. So these programs onto the memory, it takes around 39%. I don't know how much memory this computer has, but it takes 39% of it. 51 programs running at the same time. How is it possible? How is it possible? You can also watch a movie and watch typing on Microsoft Office at the same time. How is it possible? 그게 어떻게 가능하지? Assuming that process CPU can do only one at a time. So it's what is related to what scheduler is doing. Scheduler says manage programs to waiting to run. In fact, those 51 programs are actually working in this way. They keep switching each other. Once doing something for 1 second, goes to next second, it stops, and next program is doing for 1 second, another second, they go like that. So assuming 51 programs keep switching each other. While one program is running, other 50 programs are stopping. But into our eyes, human eyes, because switching so fast, it looks like everything is going at once. 실제로는 하나만 돌아가고 있는데 계속 하나 돌아갈 때 나머지 죽어 있고 그 다음 돌아갈 때는 나머지 또 죽어 있고 계속 반복이 되는데 그 순간이 너무너무 짧다 보니까 우리 눈에는 다 같이 동시에 돌아가고 있처럼 보이는 거예요. That's what schedulers are doing. Scheduler pick out each program and give it to the CPU. And maybe they stay there for maybe 100 microseconds. And then it goes to the next program until we kill one of those. So it's a fast switching of those between process, make it look like everything is running at the same time. 가끔씩 프로그램 너무 많이 돌리면 여러 개 프로그램 너무 많이 돌리면 어떻게 돼요? 우리 일반적으로 버벅된다 그러죠. 버벅된다. 뭐 이렇게 하나 열려고 그러면 툭툭툭 올라오고. 너무 많은 게 너무 빨리 바뀌려고 그러니까 이제 눈에 보이기 시작하는 거예요. 천천히. 몇 개 없을 때는 막 다 같이 돌아가는 거지. That's one way to kill your computer. You can actually burn out your CPU too in some cases. CPU에서 김 나는 거 보는 사람. CPU 태워본 사람 있어요 혹시? 네. CPU도 태울 수 있어요. 프로그램 엄청나게 돌리면 램이 탈 정도면 그건 뭐 전압이 잘못되지 않았을까? 정확하게 잘 모르겠어요. 아 메인보드 태우는 사람 많지. 그거는 이제 잘못해갖고 뭐 이제 CPU가 이렇게 박아져 있는데, 네 그거 떼고 뭐 하면 당연히 본드가 녹아요. 녹는 게 보이죠? 근데 이게 팬이 달려 있는 상태에서도 프로그램 이상한 거 막 돌리면 CPU 온도가 너무 많이 올라가면 타는 경우도 있어요. 옛날에 모니터도 태우는 사람도 있었어요. 요즘엔 좀 불가능한 얘기지만. So that's a fun exercise. 보드 태우는 사람은 많았고 옛날에. 보드 옛날에 무슨 오버클럭킹 뭐 이런 거 하다가 태우는 사람도 많았고. 그런 거는 뭐 좀 다른 얘기입니다. Utilities, tools, including programming libraries. Anything other than these four will be going into utilities. Text editor, your Microsoft Office is a utility. Programs that your Go player is a utility to do it. The system software operating system must be able to handle those programs as well. So we can use our computer in more easy ways. So hopefully that gives you idea for system software. So naked machines, it's complicated, writing everything in binary, load to a memory, each operation that we must be doing, and even your program looks all like 0101 only. So it will be very difficult to analyze. If you want to fix your program, if you write something in binary code and you realize that some function is not working and you wanted to fix it, you wanted to change something, it would be a disaster. It would be a disaster. 근데 only 30, 40 years ago, people actually did it. 옛날 사람들은 다 그 010을 다 프로그램했어요. So debugging purposes for disaster. And this is what it is. This is more of your choice. Virtual machines, write a program using text editor in high-level languages. 메모장 같은 거를 열어서도 프로그램 하는 사람도 많아요. VI 뭐 이런 거. You don't need a integrated development environment, just like Eclipse or anything that you use. You don't have to use it. Just simple text editor is good enough for the programming too. And then save to the folder, translator to convert to a binary like compilers. Use a scheduler to load and run, and use I/O systems to print out the results. Your screen, printing the result out to your screen. Your screen is monitor is also I/O device. Read something from the memory, display on your screen. So this is a step. Is nice system software can help you to do this step instead of that naked machine examples. 여기서부터 조금씩 본 건데, like I already explained, right? Assembly, a low-level programming languages. Opcode, before 0101, opcode that we studied. So, high-level languages, Java, C, Python, many different high-level languages out there. Java? I can't remember last time I did my Java programming. 기억도 잘 안 나. Probably a long time ago. Simply because I don't prefer Java. 아마 얼마 전에 한 2-3 years ago, if I need to program something, then I always did with the C. 그냥 C++도 아니고 그냥 C로 했어요. Because I was lazy. 네, ever since I got to know Python, never go back to C. 요즘에 C 안 해요. 귀찮아서. Python이 훨씬 쉬워서. Python 말고, if you're looking for any other programming language like Python, you can try something called Ruby too. Ruby라고 들어봤어요 혹시? Ruby. Ruby is also a similar language like Python, easy to use to do it. 나중에 C는 쳐다보고 싶지도 않을 겁니다. 귀찮아서. Assembly language, it's an instruction map, one-to-one to machine language, right? Each opcode that we looked at has a binary representation. So instruction mapping. Symbolic opcode, not binary. Add, store, load, compare, jump, those type of opcode that we have looked at, right? Symbolic address for instructions and data. Symbolic address for instructions and data. Symbolic address for instruction. Register 1, the address was like 100, 101. Those type of stuff are symbolic. This simply tells where your data is. Symbolic is 뭐냐? It's easy to represent. 실제 메모리 주소를 적으면 it would be a hex-digit code long. Instead of doing that, you give a name for that. Pseudo-op for the data generation and more human-friendly terms. Less human-friendly than Java, Python, but it's still better than machine language itself. So this is a boundary. This is a brief overview of the where we are. The first chapter we start discussing pseudocode, and we discuss on what is the difference between natural language that we speak, and the pseudocode. Right? Just reminded what was the part. Precise, not unambiguous, right? Clear messages. And then that can be translated into any of your choice of the high-level languages. I think one of the examples was I wrote a pseudocode. I simply translate into C-like programming. 하나 그런 예제 있었죠? 중간에. So high-level language that you speak, pseudocode, high-level language, and then goes to a naked machine language format. So there must be a type of programs that translate this into assembly. This you have to do. 그렇죠? Pseudocode to high-level language, this is your job. But after this, there are other type of system softwares that is helping you to convert everything into assembly code. 옛날에는 요즘에는 하드 프로그램들이 이렇게 짜는 게 좋아갖고 C로 프로그램 짜고 어디 버튼 클릭하면 자동으로 막 컴파일돼서 나오고 하잖아요. 옛날에는 그런 것, 옛날도 아니 지금도 많은 사람들은 그렇게 안 하고 그냥 컴파일러 이름 치고 프로그램 돌리듯이 컴파일러 프로그램 주고 거기 input 파일은 내 프로그램 파일이야. GCC 이렇게 갖고 돌리는 사람도 많아요. 나 같은 경우는 그냥 그렇게 해요. 여러분들 다운받아서 쓰는 그런 툴을 잘 안 써요. 귀찮아. 마우스로 자꾸 가야 되잖아. 마우스를 숏컷도 있지만 근데 마우스로 손이 가면 귀찮아서 대부분 그냥 키보드 숏컷으로 많이 해요. 그럼 훨씬 빠르기도 하거든요. 익숙하면. 혹시 VI나 빔 써본 사람? 들어본 사람? VI 어디서 들어봤어요? 빔 들어봤어요? 써봤어요? 쓸만해요? 별로죠? 마우스 쓸 일 별로 없죠? 근데 쓰면 그게 훨씬 편해요, 나중에. 빔으로 하면. 하긴 너무 옛날 거라. Assemblers and assembly languages, continuous assembly language process, source program in assembly language translate by the assembler, and to object program in machine language, load place into memory, hardware runs. So your compiler will be translate something into assembly language. Then assembly language will be source program. It will be assembler. Some program called assembler will translate that program in assembly into object program. From this point on, this is binary file. Binary file. So even if you try to open up the binary file, it looks very weird characters. You can't read. 바이러스나 it's the people who try to detect the virus, worms. They actually try to take a look at this object files and do backward. This downward is people like us. But some people wanted to see what this program is doing, so they actually do the backward. 어떤 사람들은 오브젝트 파일을 갖다가 거꾸로 어셈블리를 보고 싶어하는 사람들이 있어요. 이렇게 하면 완벽하게 어셈블리로 나오진 않아요. 옵코드로 나오진 않은데 그래도 조금씩 나와요. 그거 보고 유추하는 거예요. 일반적으로 바이러스 갑자기 새로 나왔을 때 아까 그런 바이러스 회사들에서 안티바이러스 회사들에서 그 바이러스 얼른 가져다가 EXE 파일 같은 거 가져다가 어셈블리를 얼른 만들어가지고 그거 보면서 공부하는 거예요. 여기서 갑자기 메모리 일로 점프를 하네. 이러면서 왜 점프 있었지? 그죠? 어셈블리 그 오퍼레이션 중에 점프 있었죠. 이거 봐라. 점프를 메모리 이쪽으로 점프를 뜨네. 그러면 이제 그 메모리 가서 이게 뭔지 보는 거예요. 근데 완벽하게 바뀌진 않아요. 근데 일반 사람들은 우리들은 그냥 위에서 이렇게 아래 내려오지. 프로그램 짜면 어셈블리로 코드가 바뀌고 어셈블리가 어셈블러가 어셈블리를 읽어서 오브젝트로 바꿔주고 메모리로 오브젝트 올려주고 그 스텝이에요. This is just what I just explained. Assembly language, assembler, machine language, object program, loader, into the memory, hardware. As soon as it's in the memory, then CPU will take it over and do whatever it does and produce a result. So this is a one step, one cycle of how your high-level programming into this machine level. Without system software, you should go right away from human beings to here. 시스템 소프트웨어의 도움이 없으면 이거 하나도 못하고 사람에서 줄이 그냥 일로 꺼지는 거예요. Then you have to do everything binary. Okay? So it's much more convenient way of doing it. And this is assembly example that we know. You already studied. Next step, load X. Load X. Put whatever value of X to register, given register. And this is opcode. Opcode, this is same as opcode of load. And this is address field, X. And explaining what it does, comments. So 이게 프로그램 한 줄이에요. Assembly language program 한 줄. Load X 이러면 it's not a program, but explaining what this one just did. Okay. So label is an option. Optional name for this instruction's location. Opcode is mnemonic address field translated into a machine language. 그냥 unique name to opcode. 그죠? Every opcode has a unique code that was mentioned in the previous chapters too. Comments are ignored by assembler. Comments, this put X to the register, this one will be ignored by assembler. Assembler program that understand this, what this means. 이거 바꿔줄래? machine object로, machine language로. Just for us to memorize, to remember what this was. So I will probably ask you one of your assignment, try to program that way and also put this comment, also write about the data sets as well as a labels. We'll see what it means later. So it's a typical assembly instruction set, like instruction sets that we know. Load X, store X, that's a corresponding binary code. Load X will be translated into 000, store X 001. This is what that means. Register R will have this value. Explain what this is. And this is instruction sets. And this is corresponding binary code. So when I ask you to write a assembly language program, you'll be using this. See? 이거를 써서 짜면 되죠? I'm sure you remember from those examples of if statement and looping examples in assembly. Back then we called it as a machine language, but it's, to be more exact, it's a assembly language. Advantages over a machine code. Assembly is better. Why? Clarity, readability, and maintainability. When I was explaining the Python code, I was emphasizing on the one factor also. Make it nicer looking. Good organization. I mean, even if your code probably not working, make it pretty might be helpful later even. Comparing to machine code, of course, it's relatively easier to read, but not as much as the high-level languages. Can be placed in different location in the memory. Okay, that's also good good advantages. Sudo op. Comments in the program directly to the assembler, not converted to machine instructions. It's okay. I mean, it's not. It simply means it does not require extra step to translate into machine languages. So it speaks the instruction clear. Instructions are clear. And you can add a stuff like this, begin and end, to mark where instructions are. So the examples later here, it goes like this. 여긴 begin and end가 없네. 책에 보면 있어요. So later example you see they say dot begin, dot end, in the beginning and end of the assembly language. They actually mark it. This is beginning, end, and also other parameters that you can use to describe where your data are and what your current data value. X dot dot data 12. So location X, now the current value is 12. So if you actually write this, it's not required part of the programming, but if you write this side by side to your assembly language, it will be easier to track of what your program is having at this moment. 쉽게 얘기하면 이거는 안 적어도 되는 문장이에요. 이렇게 옵코드로 쫙 프로그램을 짜잖아. 그 옆에나 아래다가 이렇게 쓰는 거예요. 현재 x의 값은 12다. 이제 아래 가면 바뀔 수도 있겠지. 뭐 add를 할 수도 있고 subtract 할 수도 있고. 이런 식으로 데이터를 적으면 좀 쉽게 내 프로그램이 지금 어떻게 돌고 있는지 왜 손으로 직접 넣어가면서 해보라 그랬잖아요. 하나의 방법 알려주는 거예요. So typical assembly language program structure. They declare this is beginning of the program and the program, and they also describe the current data sets, which data has what value, and this dot data, dot begin, dot end. It's a typical step. Then you write your program inside right here. And this is an example of on your right side, on your left side, is a high-level language expressions that we also looked at. So x equal y plus 3 is more of a C-like. If I put a semicolon, it's a C. So if I translate that into this assembly code, load y, probably y is loaded to some register location, this memory space register, and then add 3 in that register's location, register, add load y 하면 register 1 will have a value of y, and add 3 then we'll add value to 3, and then store x. Whatever in this value, register 1 will be going to x, location of an x. 여기 있는 값이 x로 들어가게 된다. Okay. And then later it says x, data 0, x is initially 0. They explain what the value of x in this program. Then y, data 5, y is initially 5. 3, data 3. 3, they have to know what 3 means too, right? Means actually it's just 3. So they explain the details of this data, what's actually in X and Y and 3. They explained it in this way too. 실제 Y 값이 뭔지 X 값이 뭔지 실제 3라고 써놨는데 이게 숫자 3이라든지 그렇게 표현을 해놓은 거예요. 이건 뭐 쉬운 예제니까 얼핏 봐도 감이 오겠지만 좀 복잡하면 저런 게 써주면 훨씬 프로그램 읽기가 편하겠죠. This one is very similar to the ones that we've seen. Input A and B. Probably in Python way, they input A equal input, that waiting for user input, B equal input, user input, just like the average miles per gallon program that we have looked at. So while A is greater than B, then do print A subtract 2. Translate it into this. 전에는 이게 안 나왔었죠? You can actually define a structure here. So this is loop 1. So if somewhere in the program they say jump to loop 1, it will go to right here. In input A, input B, loop 1, I'm going to define load A, compare to B, load A to a register location. Whatever that written in that register, I'm going to compare it to a B. If still data is 0, 0. Jump pointer to loop to end. 여기. Jump, whatever the result is, it will go to jump pointer to loop end. Loop end is right here. So, otherwise, I can go back to loop 1. 여기. Jump to loop 1. So I keep going back. If my conditions are met, then I can go to loop end. So again, it's a bit dumber way of writing a loop, but it will be a good practice of translating this to a machine language. So naturally, your assembly language will be much longer, and you have to be careful. You have to be very careful when you try to translate that from high-level language to assembly. 훨씬 신경 쓸 게 많겠죠? 그죠? 제대로 점프하는지도 확인을 해야 되고, 잘못하면 뭐 딴 데로 가갖고 룹 안에 안 들어갈 수도 있고, 또 레지스터만 가지고 하다 보니까 그냥 쉽게 하는 게 아니라 한쪽에 로드 해놓고 또 애드 하고 이런 거를 단순하게 생각을 하면 안 되니까. So only one way to do this is practice more. Practice. Even in your textbook has good examples on it. Your few assignment questions will give you a chance to translate. So practice is the only way to see how you do that more easily. Do this. 이거 어떻게 해? This one example is it's a pseudocode. They ask you to translate the pseudocode into assembly language. It's doing a computation of a sum of the non-negative numbers. Non-negative numbers. Set the sum of to 0. Input the first number n. While n is not negative, do add value of n to the sum. Input the next value of n. End loop. Print out the sum and stop. 뭐야? 얼핏 보는데 what does it do? 뭐 하는 것 같아? 수도코드. 수도코드 깔끔하잖아. 이게 뭐예요? 엄마? 아직 수도코드를 보고도 감이 안 와? 큰일 났네. 기말고사에 내가 어려운 수도코드 적으라면 어떡하려고 그래요? 어? 물어보기도 참 애매해. 이거 하는 알고리즘을 주세요 하면 너무나 다양하게 적어놔서 점수를 줄 수가 없어요. 그래서 빵점 아니면 100점이야. 그렇지 않겠어요? 내가 돌아가는지 안 돌아가는지 알 수가 없는데 부분 점수를 어떻게 주겠어? 그치? 이거 뭐야? 계속 주는 값을 계속 더하는 거잖아요. 그죠? How can you implement that in the assembly languages? 문제 그런 식으로 나와요. Midterms and final will ask you that. Give you a set of pseudocode, explain what this does, and what is the problem of this pseudocode. Can you fix it? 그죠? One of your assignment questions also is very similar, right? They give you a set of code and explain what was a potential problem with this code if input values are A and B. 그게 나왔죠? 안 나왔나? 어사이먼트 1번 질문이 그런 게 있지 않았나? 그쵸? And also ask you to fix the program so you can cover up all the possible error cases. 이건 더 어렵다. Assembly direct translation of the program. So begins, dot begin, clear sum. Okay, that is corresponding to line number 1 of this clear sum. Step 1. And then 뭐냐? Input, get an input for n. That is line number 2 of the pseudocode. And then they put a comment like the next 3 instructions test whether n is negative number or not. So these 3 lines corresponding to line number 3 in the pseudocode, checking for whether n is negative or not. If it's negative, do what? Don't go to the addition loop. You probably go back to the beginning or something. 이렇게 하면 어디 가나요? Jump to neg이네. If n is negative, it says jump to neg. Neg. Out sum and finish. If the negative value is entered, then it say halt means finish. Stop and line. So 여기는 안 가죠? 그죠? Because I just jumped. 옛날에 베이직이나 뭐 이런 랭귀지로 보면 혹시 그런 거 해봤나 모르겠는데 걔네들도 하이레벨 랭귀지인데 약간 어설픈 하이레벨 랭귀지 이렇게 하고 걔네들은 라인 넘버가 10, 20, 30, 40 이랬어요. 그래서 걔는 그런 명령어가 있었어요. 하이레벨 랭귀지인데 불구하고 go to line 20, go to line 40, similar to a jumping operation. 옛날엔 그래서 나중에 프로그램 도다 보면 하도 점프를 많이 해갖고 내가 어디 가는지 잊어버려요. 예를 들어 라인이 한 1000줄 되는 프로그램이면 계속 점프하다가 something that you don't want to have. So nowadays it's more easier to keep track of. 혹시 베이직이나 이런 걸로 해본 사람 없어요? 베이직이 맞나? 튜어링이나 이런 거 혹시 안 해봤구나. 그런 랭귀지들도 있어요. We'll call out the attendance now.